Okay, this is lesson 30. This one is a little hard, but I'll show you how I did it and how I used the chart to kind of help me and try to gauge what was what based on the numbers. So I'll be going between this page. This is all the ones he showed us, the different compounds with their names, and then also the chart over here. So let's start with looking for 2983W. I think this one I actually couldn't find because there's no W on here. So I went ahead and skipped it and went to 1743S. And also what I have like a notebook and I wrote down what each of the numbers corresponded to, and then I put it together with looking at this and what fit into there. So 1743S. And look, it's an ester because it belongs in between here. So I'll go on to 1243S. I see it would be an alcohol, ether, or ester. And then, let's see, 1048M. I believe this one I couldn't find either. So I see ester, and I'm gonna assume it's an ester and ester. So I'm gonna look at the only one that has ester. So I'm gonna put this one in. I like to draw the compound, which is carbons, and then replace the carbons that I need with oxygens. So I believe it was this one, and then I go back over here, and I see it's the third one from the left. Add my hydrogens. Oops. And let's see, that's what it looks like. So ethoxy, and then a carbon double bonded to oxygen. Ethoxy, carbon double bonded to oxygen, and a carbon. And then if you just want to count your hydrogens and make sure that you have 8 hydrogens and 4 carbons and 2 oxygens in each of your compounds. It's pretty easy to add another carbon by accident during this lesson. Okay, I'm going to look for the 3500 to 2500 BR. And I'm going to assume this one because it goes all the way down to 3500, whereas this one only has a small amount of range. So it's an acid. So I'm already thinking that it's going to be my carboxylic acid. So I'll just go ahead and do that already. Save some time. And then now I'm gonna replace my oxygens, or my carbons with oxygens. And I believe it was this too. Let me go back and look. Yes. Add my hydrogens. And this is the carboxylic acid. And also if we look at the 1712 one, just to do it, I believe that is a ketone. Yes. So we're right on track with this one. Okay. 2934 I already know is going to be, a lot of these that you get are going to be alkanes, which just means it's a carbon single bond. So let's look at the next number. 1730, so I'm going to go over here, 1730S. So it's an aldehyde, but we don't have any aldehydes here. So I'm going to go with the next best thing, which would be a ketone. So I'm going to write that down as ketone. and then 1126S. Mm-hmm. 1126S. So it can be an alcohol, an ether, or an ester. And with these, I know if it's ever an alcohol, it'll be like the first, or it'll show, where is it? This one up here, the 3500. So it's either going to be an ether or an ester. So we already have a ketone. So I'm just going to look for, right here, the ketone ether. So I'll go ahead and draw that. Let me see where the oxygens are. So we'll have a methoxy at the end and the oxygen double bonded. Methoxy. Add my hydrogens. And then I'll count them just to make sure. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Again, that's a ketone ether. I'm just double checking. Okay. Okay, so I'm going to start with a 2964, but I kind of already know that's going to be an alkene. So single bonded carbons. 2854 is also going to belong in this range. 1122S is going to be what decides what this is. So 1122F, alcohol, ether, or ester. And again, like I said, if it's an alcohol, it's going to be the 3500. That's the main component. So I'm going to go with either ether or ester by itself. And there wasn't a ketone, so I can go ahead, I'm going to go ahead and pick this one because they were all single bonded. I have double bonds here, and it just seems like it would point towards the ether. So I'll draw my 6-member ring and then replace these 2 carbons with oxygen. Add my hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. 2 oxygens, 4 carbons. Okay. $34.08. Okay, so I'm going to look on my chart. 3408. Let's see, was it S and BR? So it would be between here. So I see we do have an alcohol on this one. And I see we have 2 alcohols here. So it can be either an ether or a ketone. 2956, that one's going to be up top, the alkane. 1709S. Okay, so we have the ketone. So I can stop right there and see that we're going to have this ketone alcohol. So I'll go ahead and draw it. And then I'm going to replace this. I already know this is going to be an oxygen. And then it's an alcohol, so this is going to be the oxygen at the end. And I'll go back to this to make sure. Yes, so the 4 carbons. 4 carbons, alcohol. And none of the answers, like none of these are going to be repeated. So it's just 7 questions. Okay, 3401. Let's go over here. SBR. So this is also going to be the alcohol. And since we already used the ketone alcohol, it's more likely going to be the alcohol ether. But I'll go ahead and double check. 2949, 2823, those are all going to be the single bonded alkanes. 1072, that's going to be the deciding factor. And yes, so we have ether and ester here, so it's going to be the alcohol ether. This one over here. So 5-member ring with oxygen attached. I'm going to go ahead and replace those carbons. Add my hydrogens. And this is our end product. Okay, so we're going to go and look for 3300 SBr. 300, so we have an alcohol. 3024M. I see up here, alkene. The alkene is a dead giveaway because that means there's a carbon-carbon double bond, and the only one with a carbon-carbon double bond is this alkene diol. So I could just stop there. This was probably the easiest one to determine. The other ones are kind of iffy. So do a double bond between those two carbons, and then I'm going to replace those outside carbons with oxygen. Add my hydrogens and make sure it's right. So yep, that's what it looks like. 4 carbons, 2 oxygens, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So I believe that was it. So just, this is good practice using the chart. I know it can be kind of confusing, but just try to do like the process of elimination, and hopefully it'll help out. But yeah, good luck, you guys.